All right, today we are diving into one of the biggest, most profound shifts in how we see the world. It's the story of how we figured out the true, honestly staggering age of our own planet. For almost all of human history, we've asked this one fundamental question. How did our world get here? Was it all forged in a flash, through a series of violent, world-ending catastrophes? Or was it shaped by something much slower, by the kind of endless, gradual change we see happening all around us?
For centuries, one of those answers totally dominated. This is the story of the geological detectives who came along and uncovered the other one, cracking what is probably the ultimate cold case, the real history of planet Earth. So, where do we start? Well, for a long, long time, the main idea was that the Earth was young and that it was formed through basically chaos. This entire way of thinking had a name: catastrophism.
And when people said young, they got startlingly specific. Get this. In 1650, Archbishop James Ussher did the math based on biblical texts and announced that creation happened at nightfall on October 22nd, 4004 BC. I mean, wow. So suddenly, there was this very concrete number, about 6,000 years for the age of the Earth, and that idea shaped everything.
And that's catastrophism in a nutshell. It's the belief that our world's features, the mountains, the canyons, all of it, weren't formed slowly over time. Nope. They were carved out by sudden, massive, and often supernatural disasters. The most famous example, of course, being a great global flood. And there was even a scientific framework for this, called Neptunism. The theory was that a single massive ocean once covered the entire planet. And from this ocean, it was believed that all rocks, even something as hard as granite, just kind of precipitated and settled out of the water. It was a very neat, tidy, water-based explanation for, well, everything. But then, in the late 1700s, things started to shift. A Scottish farmer named James Hutton, a man who spent a lot of time just observing the land, started to see things that didn't quite add up. And he kicked off a quiet revolution that would, really, change the world. And this set up the great debate for the next century. On one side, you have catastrophism, a young Earth shaped by unique, violent events. And on the other, you have Hutton's radical new idea, which we now call uniformitarianism, an incredibly ancient Earth shaped not by past catastrophes, but by the same slow, steady processes that we can literally watch happening today. I mean, that is a mind-bending claim. If the world really changes that slowly, how could you ever prove it? You can't just sit there and watch a mountain grow. So where on earth could you possibly find the proof? This is where James Hutton basically puts on his detective hat. He was convinced that the clues were out there, hiding in plain sight, locked away inside the rocks of the Scottish landscape. And his first mystery to solve was a direct shot at the old theory. Where does granite actually come from? Remember, the Neptunists said it was an ancient rock that formed from water. But what Hutton was seeing with his own eyes told a very different story. In 1785, at a place called Glentilt, Hutton found his smoking gun. He saw these veins of pink granite that were literally cutting through the older rock around it. Now just think about the logic here. For that to happen, the granite had to be molten, liquid rock that forced its way up from below after the other rock was already there and solid. And here's the kicker. That meant the granite was younger than the rock it invaded, which totally flipped the old theory on its head. This was the proof for a rival theory, Plutonism. The idea that rocks aren't born from water, but are forged in the immense heat and pressure deep inside the Earth, from fire, not flood. But Hutton had an even bigger mystery to solve. He kept finding these rock formations where the layers were just stacked at completely bizarre, impossible-looking angles. How could a single great flood ever explain that? The answer came to him in 1788 at a coastal spot called Siccar Point, and what he realized there just blew his mind. He was looking at an epic story told in stone, a story that had to have happened in at least 4 acts. So, first, you have sediment-forming flat layers at the bottom of a sea. Second, some incredible force from deep within the Earth tilts those layers completely vertical.
Third, a huge amount of time passes, enough time for erosion to grind the tops of those vertical layers totally flat again. And finally, fourth, a whole new sea forms on top, and new horizontal layers are laid down over the old ones. When you piece that sequence together, the conclusion is just inescapable. A cycle of creation, upheaval, destruction, and then creation again. There is no way that happens in 6,000 years. It required a span of time so vast it was almost beyond human imagination. Hutton had found his proof. The clues were undeniable. It was time to write a totally new story for the Earth, one built not on disaster, but on an incredible amount of time. He captured his whole philosophy in this one brilliant phrase that became the foundation of modern geology. The present is the key to the past. What he meant was, the same slow forces we see today, a river eroding a bank, sediment settling in a lake, if you give them enough time, they have the power to build mountains and carve canyons. But an idea this revolutionary doesn't catch on overnight. In fact, when Hutton died in 1797, his theories were still pretty much ignored. It wasn't until the 1830s that another geologist, Charles Lyell, wrote a massively influential book called Principles of Geology, where he championed Hutton's work. That was the book that finally pushed the idea of an ancient Earth into the mainstream. And it profoundly influenced thinkers like a young Charles Darwin. It made uniformitarianism the foundation of science as we know it. So together, these geological detectives had done way more than just argue about rocks. They had completely shattered that 6,000-year timeline of the world. So how old is the Earth really? Not thousands of years. We're talking billions. The modern, scientifically accepted age of our planet is 4.54 billion years. A number so big, a concept so profound, we now have a special name for it: deep time. And this staggering amount of time is the fuel for Hutton's greatest vision, the rock cycle. It's this constant, unending engine. Magma cools to make rock. That rock gets eroded into sediment. That sediment gets buried and cooked by heat and pressure, and eventually melts back into magma to start all over again. In Hutton's famous words, he saw no vestige of a beginning, no prospect of an end. You see, this whole scientific revolution, it was never really just about rocks. It was about discovering the single most powerful and creative force we know of: time, an almost infinite amount of it. The discovery of deep time didn't just change geology. It was the key that unlocked modern biology. It made Darwin's theory of evolution plausible. It gave us our understanding of the cosmos. And that leaves us with one final, awe-inspiring question to think about. What else becomes possible when you have billions of years to work with?